to the C21U seminar series. Before we get started, I just want to remind everyone to turn off their phones if you haven't done so already. And today it's my pleasure to introduce Madaio. He is a second-year master's student in the digital media program. He works with me in Photos. And his research focuses, and you might can tell, on educational technology. And he's been a research assistant at the C21U for about a year now. Before that, he taught for 4 years at a public high school in Washington, D.C. And he also has his master's in education from the University of Maryland. And today he'll be presenting a portion of his master's thesis, which is about the capabilities of adaptive learning systems and the possibilities of their use in higher ed.
Thank you, Lauren. Before we begin, I just want to thank Rich DeMillo and the Center for 21st Century Universities for supporting this research here. As Lauren said, most of my research focus in digital media is on in media studies approach to education technology. So understanding what the technology does, how it works, and then how that affects the culture of education and the cognitive studies, the cognitive science approach to how students learn. Okay, so today we're talking about adaptive learning systems. So what are adaptive learning systems? What is adaptive learning? At its heart, it's personalized learning, personalized, individualized learning. And these are systems that offer support for teachers in personalizing learning at scale to their students. So that means individualized difficulty of content, maybe individualized form or media of that content, but also supporting teachers and allowing students to learn at a pace and a sequence of learning that is most appropriate to students. Now this could be based on student knowledge, student performance on prior learning, but also some of these systems offer adaptation to student learning styles, student learning preferences, or goals. So you might be thinking at this point, well, this seems like just good teaching. And that's true, and differentiation is always a goal of good teaching, but differentiation becomes difficult at scale. So personalized learning, although of course it has been around for thousands of years, going back to Socrates and the Socratic method, one-on-one personal tutors. Again, that becomes difficult when, say, in 20th century education, we began putting more and more students into a single classroom with a single teacher. And those students come from many different backgrounds, with many different prior knowledge states, knowing many different things, and having many different needs. So for a single teacher to differentiate their instruction requires support. We saw in the early 20th century education reformers such as John Dewey and the Montessori program trying to scale personalized learning outwards to whole schools, whole school districts, but they ran into challenges of being able to track individual students at small levels of granularity. In the mid-20th century, the 1960s, we saw a push for mastery-based learning, Howard Bloom, where students progress through content once they've demonstrated mastery of previous content. But again, there's an issue here of scale. So if single students demonstrate mastery of one part of the course before other students, how is it that a teacher can manage all 30 students or more in a class moving as a single cohort in that domain? The 1970s and 80s saw a rise in computer-assisted or computer-aided instruction, along with the development of cognitive tutors to try to provide some computational supports for individual teachers trying to personalize learning. But most of the work that was done was at a large level of granularity, meaning students progressed through a domain, they took a test at the end of the course, and that determined whether they were assigned to a different course in the next semester or maybe in the next month, not at a small level of granularity such as individual problems or individual topics within the course. So, why now? Why are we talking about this now? This, as I said, has been a goal for many years and has been worked on by many, many researchers in many different universities across the country and across the world. So one of the major driving factors now is a proliferation of learning technologies in the classroom. So this, of course, has been done for at least the last 100 years, trying to put educational TV programs, educational movies, educational radio into schools. But most of those have been top-down, where schools expend a lot of money trying to put these technologies into the classroom that are not always adopted by teachers, or not always able to be adopted by all teachers. So what you're seeing now are students bringing their own devices. And this, of course, so I'm talking both about K through 12 schools and also about higher ed, where in K through 12 you're seeing lots of schools and school districts in the last 10 years allowing students to bring laptops, bring tablets, bring smartphones that could provide platforms for adaptive learning systems. You're also seeing a rise in learning mediated through technology. So I know a lot of the work that Lauren has been doing here at C21U on researching flipped classes, understanding how that works, and also a lot of the larger work that C21U does with supporting faculty research on MOOCs, or massive open online courses. So you're seeing just a larger movement towards learning as at large mediated through or experienced through technology. Also, you're seeing learning apps and emergent student collaboration on forums such as Piazza. So all of this is leading towards a larger volume of learning data generated on students. Some of these terms you see here are some that proponents of so-called big data analytics use, where millions of students might be using a learning management system. So that platform, that software, has access to large numbers of data about students, as well as a greater variety of student data. Velocity, meaning the frequency of data generated, is higher. It's not simply an end-of-course assessment or maybe an end-of-unit assessment, but they're able to get feedback and get data on student learning on a day-to-day or even hour-to-hour basis, and we said a smaller granularity. As well as improvements in the analytics and both the technology, the hardware, the software for big data analytics, such as programs like Hadoop and MapReduce, which allow single technology providers access to the open source tools to do big data analytics on terabytes worth of data. And also large-scale systems, just improvements in machine learning in general, and the ability to cluster students in related groups across not just a single class, not just a single school, but for a technology provider or a company that has access to millions of students using it. They can identify which students have related needs or related knowledge in order to provide recommendations for learning. So this is just at a large glance the method for adaptive learning. You might notice similarities in this clustering recommendations to other popular technologies like Netflix and Amazon, and the way that they use machine learning to cluster their customers into related groups to better offer more targeted, more personalized recommendations. So at a large scale, the potential for these technologies, and I am, as many of you should be, wary of claims for the potential for learning technologies, but at a large sense, there's potential for improved student engagement if they're able to access content that is appropriate to their level of mastery. They're not working on content that is above their level or below that level. And we've seen that as a goal for education for 100 years with Vygotsky and the so-called zone of proximal development, where students are working at an ability level that's right for them, and they're not bored because maybe it's too easy, or they're not frustrated because it's too hard. Again, though, I am wary, and I urge you to be cautious of claims for easy and effective engagement. Improve student performance on learning outcomes, improve student retention in courses if they're less frustrated or if they're not able to master the content, they might drop out. And the potential with access to all this data for improved research-based interventions. So some of the challenges, material challenges, such as access to bandwidth. Now this might not be a challenge, say, for Georgia Tech, but for a public high school, which might not, again, or if it has Wi-Fi, might not have supports for hundreds or thousands of students at the school to access simultaneously. And this is a focus of Obama's Connect Ed initiative to try to get broadband and wireless access to 99% of public schools in the next 5 years. Access to laptops or tablets for students. Again, if at a university setting, students might already have laptops, but we've seen initiatives in, say, Los Angeles to provide tablets for all students running into many, many obstacles. And then the cost to license software. Infrastructural challenges, such as system setup and support from IT departments at schools, integration with existing LMSs or learning management systems. If a school has been using, say, Blackboard or T-Square for the last 10 years, how able are these adaptive learning systems to interface with their existing LMS and provide recommendations that can be woven into or fed into the existing LMS. There's also, of course, the infrastructural challenge of the training and adoption curve. Does the school need to provide large-scale professional development to its faculty? And the adoption curve of are faculty willing to adopt, and which faculty, right? Of which ones are the early adopters, which ones are the resistors. And then finally, pedagogical challenges, such as integration to existing teaching processes. Does this interrupt their usual process, or does this supplement it? The challenge of course author. Some of these providers are integrated with publishers. So the textbook publisher, for instance, such as Pearson, they partner with an adaptive learning system called Newton, where the content is already provided for the teachers. Depending on the school, depending on the teacher, that might be a welcome solution. Some teachers, some schools might want their faculty to author their own course content or upload existing course content. Challenges such as the accuracy of recommendations, which while it's being improved and improves as access to larger numbers of student data, larger amounts of student data increases, is still an issue. And then of course, the social dynamics of self-paced learning, which is a topic that interests me and I think is a rich avenue for future research. If this provider, this platform, is tied to an online course, it's not really that much of an issue. The student can work through the content at their own pace. But if teachers are using this in blended classes and face-to-face classes, how is it that a whole course or a whole class can still exist as a phenomena, as a culture, as a group, if each student is at a different place in the content, or is mastered differently? Okay, so our current adaptive landscape we'll be looking at 16 major adaptive learning providers of varying sizes and varying platforms and publishers, currently used in several different public and private universities, and by a variety of public K-12 school districts, even also used by corporations and individuals. So to sampling some of these major or larger companies, ones like Newton, which I mentioned, Cerigo, Cogbooks, Dreambox, some others, Smart Sparrow, Carnegie Mellon's Open Learning Initiative, which is sort of on the border of a intelligent tutoring system, which is a micro-scale adaptation on giving feedback to individual problems, but also on the border of the larger scale adaptive, meaning adapting through an entire course. And we'll talk in more depth about each of these. Also one like LoudCloud, which C21U and Georgia Tech are in talks with now to get access to the research. So just at a glance, some of these providers are platforms, meaning they allow teachers and schools to upload their own content or create their own content for. And some are publishers. Some work with publishers to create their own content. Some are considered resources, where they're not meant to provide a whole course sequence, but offer quizzes or offer individual training. So I've included on here, and you can see there's a menu over there, Khan Academy, which offers individual modules for single topics, and, such as videos, training videos, but also problems and exercises. They're on the cusp of being a resource, such as providing these individual topic resources, but then also offering whole courses if teachers want to use a set or a sequence. Some have target users, post-secondary education. Some are more targeted to K through 12. Some, such as Khan Academy, might be more targeted to individual users. And individual users can get access to it. They don't need to purchase logins. And then some are more targeted to corporate. Yes?
What do you mean by platform and publish? Are you going to explain those?
Mm-hmm. So the platform, meaning the teacher of the school can upload their own content or can author their own courses on there. Whereas the publisher model would provide a pre-authored course for the teacher.
Okay, so it can be one or the other. Okay. What's resource?
Yep, so do they offer individual modules? So in the clearest example of this is something like Khan Academy, where it's resources that students can just access at will. They can say, watch a video on polynomial equations or quadratic formula, whereas the whole course module would require them to sign up for a course.
So on Khan Academy, we could actually publish to that here at Georgia Tech?
Khan Academy is listed as a platform.
Yes.
So depending on the agreement you have, some schools have agreements with Khan Academy and are able to upload to there. But you're right, that one is not really as much or as open a platform as some others. So for a lot of these though, they do require subscriptions, they do require partnerships with the company and an institution. So most of the ones that are listed here as platforms, individual users, or the average person can't just log on and just upload content to it.
The granularity here is kind of at the hour-long lesson, and it's much coarser than intelligent tutoring. So
depending, yeah. So some offer the granularity of quizzes or single assessments, or for the learning objects. Might be a lecture of varying size, or might be single text documents or PDFs. And that's sort of the domain platform, the domain model. Meaning how they represent the course domain varies from company to company. I'll be getting that in the comments.
It's also a mixed bag, right? It's content and meta content. So Newton isn't really a supplier of content; it's a supplier of content about content.
Right. So what Newton offers to the publishers that they work with are the tags for which course elements are a prerequisite for which, and then they offer the algorithms for inferring student knowledge based on performance and the recommendation algorithms they provide for this. And some have opportunities for LMS integration. Khan Academy, which mentioned, Duolingo, and the two of these are the more popular, meaning maybe less institutional, more for individuals to access. So a couple of sites. Arizona State University has partnered with Newton for the last 4 years, and their Emporium math courses report a 18% increase in pass rates. This is from their research, 47% drop in student withdrawals. Their leadership estimates that they retained 12 million in what could have been lost revenue. Sorry?
what does that mean?
So that is their estimate for the amount of students that stayed with the courses and stayed at the university that would have otherwise been on the cusp for withdrawal from the course of the university. And then Smart Sparrow was developed at University of New South Wales from mechanics courses and saw a decline in dropout. So some of the problem with this research is that it is too, it's not really generalizable yet. And really because it's only been done at individual universities, A lot of this are their estimates that from their white papers and their publications, and are not really rigorous research on the effects of it. Maybe not necessarily with a control and an experimental group. So these are from Arizona State University's public documents about their work with Newton, and are not from peer-reviewed publications.
So the lost tuition revenue has become a sort of standard return on investment metric. So if you, and a lot of places are using it. So if you admit a student and that student doesn't go on for a degree, then you've lost, that revenue that would have resulted in a degree. You can use that to apply to other resources. Georgia State uses that. Arizona State uses it. There's kind of a national consortium of institutions that agree to use that.
And I think to me, what these results or what these numbers indicate is really a promise of potential and less of verifiable results. But I think what it does indicate are opportunities and need for more controlled research.
You're familiar with Duolingo, and I saw in your previous, so it said K through 12, so a school, high school, or can incorporate Duolingo into their classrooms so the students do the lessons and then
Yeah, so Duolingo does not have integration with the LMSs, the learning management systems of the schools.
You put down here K through 12, I guess, but it's on an individual basis.
Yeah, and some teachers are adopting it for their courses, but they're not able to integrate it into the existing grade book or the existing course elements. And we'll get more in depth into each of the components of the systems. So some other institutions that are working with these, Carnegie Mellon, OLI, some smaller research universities, University of New Hampshire, and also some online universities. As I mentioned, there is a lot of desire for this for online courses because it's easier to self-pace students in an online course than when you have a cohort model. Okay, so this next section will be the components of the adaptive systems. There's three main components three main components. The domain model, which represents the course as a set of course elements and understands how they are linked. The learner model, which models each individual learner's knowledge state, prior knowledge. Some offer a model of student learning goals and learning styles, although those are much more controversial. And they have limited effectiveness. And then the adaptation model, meaning once these two are taken into account, how does the system actually adapt the course or adapt the content? So the domain model, as mentioned, is a conceptual map of the course or domain, where course elements are assigned to nodes. And those course elements, I think this was what Jimmy mentioned about the granularity. Those could be either learning objects, such as teacher-provided videos, lectures. Those could be articles, PDFs, or some, like LoudCloud has a textbook woven into the system. Those could be course assignments, exercises, quizzes. And again, they vary whether or not they are created by the teacher, created by the provider. The edges, the links between the nodes, are the hierarchical relationships. And those could be linear in the sense of maybe you need to, say, learn addition before you learn multiplication. Or those could be nonlinear or parallel, where maybe there are 3 or 4 different course elements that you don't need. One is not a prerequisite for the other. It could be undertaken simultaneously. And those prerequisites are typically included in the metadata for each of the nodes, meaning which one is a prerequisite for the method for this domain model, as mentioned, can be created by the provider or by the teachers. Some adaptive systems use pre-authored content. Some allow for teacher authoring and arrangement. Arrangement meaning deciding which nodes are prerequisites for which other ones. Multiple conventions for domain representation, navigation. Those are things drawn from say, GIS or mapping systems where you can move, you can zoom, you can pan across the domain, you can filter. So there are trade-offs for teacher autonomy or for the effectiveness of the system. If the teachers are able to create their own content, they might have more autonomy, might have more agency, and might have more buy-in into the system. But there are risks for the consistency of the tagging. Maybe they don't consistently tag which course elements are prerequisites for which other ones. And maybe they don't tag enough of those, or the quality of the tagging or the metadata isn't enough to allow for accurate recommendations. So those are trade-offs that the administration or teachers selecting which of these to use might need to decide. And they also have different abilities for students to view their own so-called position in the domain, meaning where they are in the domain model. Some allow for students to see the entire domain. Maybe they see everything that they need to do after where they are. But there are some risks for cognitive overload, feelings of frustration.
Question?
Sure.
Can you give a sort of concrete example of how this is used in practice? I'm sort of following on a theoretical level, but I'm not familiar with implementations of this tagging system.
So, for instance, this might go a little bit. There are a certain set of competencies. This is the knowledge of what an integer is, ability to add two integers, subtract, multiply, etc. And the teacher, in order to get from A, knowledge of what an integer is, to the ability to solve equations F, would either the teacher or the platform would need to determine, okay, is knowledge of what an integer is a prerequisite of the ability to add or subtract two integers, and which, so for, say, ability to divide or multiply, which ones of these are prerequisites for the other.
How would a teacher use this information in practice?
So some of the systems allow a teacher to, when they're setting up their course in the summer before they start teaching it, divide what they want the students to know into these learning goals, learning outcomes, and for each of those, say, okay, I have this lecture, maybe it's the course they've taught with the MOOC, so they have 15 10-minute long lectures, or 30 or so, and each of those to establish one as a prerequisite for the other, and identify and say, in order for students to get to here, they need to know X, Y, and Z, but they can't know this before that. So,
and would it be a computer program telling the students what to do next?
Right. Most of these are instantiated into a online browser. Some have mobile apps, but most are browser-based. So the authoring system would be browser-based as well. The teacher would have their view of the system as they set up the course, as they author the course, where they could import their own course videos, import their own documents, import their own exercises or quizzes or assessments. Some operate in similar ways to Coursera or edX or these other platforms.
Also, feedback to the instructor, right? So the instructor may see a dashboard that shows how students are progressing through these charts. The student may not see that, but the instructor can see how things are going in the class as a whole.
Okay, this is another example, though. And this is not a teacher-facing view, but this is an example from Newton, I believe, of the complexity of some of these and the risks for allowing teachers to author their own. Okay, so just as an overview of the domain model, and you can see it's sort of mixed, right? Some of these allow teachers to create their own and arrange meaning establish prerequisite relationships. The discovered content piece, some systems such as LoudCloud discover content that is related to the topic that's available, open educational resources or Khan Academy videos or instructional YouTube videos. But of course there are very much risks for misidentification of discovered content or appropriateness difficulty that's not related. The visualization, some are strictly teacher viewable visualizations of the domain. The sort of node link network of where each element is, and some are visualizations provided to students. Okay. For the learning model, so this is a model of each learner's current knowledge state. Could be what they call an overlay model, meaning where an individual student's knowledge is compared to the overall domain, or a stereotype model, where individual learners are clustered or compared to other similar learners, and then each cluster then is compared to the overall domain. Of course, both of these are based on assumptions. The stereotype is based on assumptions about student similarity, that you can know how students are similar based on how they've performed on previous content. If I know, say that Jim has mastered these 3 content elements and which has mastered the same 3, the learner model would potentially offer a similar recommendation to both of them, knowing what it knows about them. The overlay model is, of course, also based on assumptions that the overall domain is what each student wants to work towards. So this data is collected either statically or dynamically. Statically meaning once at the beginning of the course, and it's assumed to hold true throughout the rest of the course. Some of the static data tends to be cognitive characteristics or prior background knowledge that they assess once at the beginning through a survey, through maybe a pre-assessment test. Challenges to that is that maybe these cognitive characteristics don't hold static. And that would be things like working memory. Cognitive, or sorry, non-cognitive, maybe topic preference, learning goals. These can be either explicit, such as a survey. The student knows that he's being surveyed. He knows that data is being collected on him. Or feedback about how well did that previous learning object meet your learning goals. Or these could be dynamic and implicit, meaning it's automatically collected through interaction with the system, clickstream data, time spent on each course element or the LMS as a whole. Learning style, which could be static, or could be explicitly assessed in the beginning of a survey, could be inferred. Knowledge state based on performance of, on individual assessments. This dynamic data is data that's assumed to change over time. Of course, each of those has their own risks. Explicit is non-completion. If a student's given a survey, they might simply not complete it, or might be inaccurate. It also interrupts the learning process if they're given a feedback prompt after every question. Risks for implicit are the provenance of the data, the accuracy of the inferences made of the data, and then of course data privacy issues, which has become a large hot topic in K-12 education technology, and may provide roadblocks to having access to a large enough amounts of student data to provide accurate information. So this is an example of one potential walkthrough. The student takes a learning style survey perhaps in the beginning. A learning profile is established for them. They see the sequence of course content. Recommendations may be provided. They work through tutorials, examples, take assessments, further recommendations are provided. This is a similar, less system architecture for interface, student account, course database. All these slides will be available on the C21U website if you'd like to take a closer look. I do want to. So this is a taxonomy of some of these. All of the ones that I looked at had assessments for student knowledge state. Very few had assessments for student learning style, and that is not necessarily supported by research in education psychology. That learning style holds consistent over time, or is a consistent marker for student performance. Student learning preference, simply what do they want to learn, their goals, and then creation of a learning model based on clickstream data interaction systems. Okay, and lastly, adaptation model. What is unit of adaptivity? Is it the difficulty of the content? Is it the media form? Is it the sequence of content? Micro meaning how they move through individual problems or multiple problems. Macro meaning how they move through an entire course. And then adaptivity on the method could be direct or indirect presentation, and then a variety of algorithm types. These are some of the algorithms. I'm going to move on. We could very well talk more in depth about the genetic algorithms, neural networks used to infer learning styles and interactions, used to refine models, construct optimal learning paths, Markov models to predict likelihood of learner success based on similar student characteristics, and the Bayesian network tracing for clustering students and groups. Some are direct, meaning students know what is being adapted. They see that they have a choice. You could learn this next or that next. The method is indirect, where the so-called next learning object is presented without the students knowing that there was even an alternative to that. Both have risks and trade-offs. The system controls too much, the feelings of paternalism, lack of student agency. The systems that have learner choice about what they want to learn next, students might not always know what is the optimal path or the optimal next learning object. There's research in education psychology on the novice-expert trade-off, that novices may not know what is the most optimal next item. Now, this could be mitigated, it could be supported through recommendations by the system, but in and of themselves, there are risks to allowing free learner choice. And of course, it goes without saying, but I would say that the design of the adaptation engine necessarily influences the learning process. So as potentially researchers or potentially teachers or administrators trying to select an adaptive learning system, it's important to consider how the way it adapts the material is going to affect the learning. So this is not very elucidating diagram from Smart Sparrow, but might give you an idea of the overall flow through a domain with lecture videos and projects maybe leading to another video, or might be leading to a assessment. This is, I think, maybe this is what you were asking about. This is a student view. I know you're asking a teacher. This is the student view for Newton, where they can see what the next activity is. Although this one is not visible to the students, that they have a choice of what to learn next. They provide a recommendation for what is best to learn next, and they. Okay, and then some of these systems all allow for adaptive pacing, or allow for students to move through the content at a pace of their choosing. Most allow for adaptive sequencing, or the choice of which learning objects they want to learn, or what the path through the content is. Fewer provide adaptivity on the content type, the content media type, meaning video or document, and less offer adaptivity on difficulty, simply because of the difficulty of providing a large enough range of difficulty in exercises or problems, or having, say, parameterized problems that can increase. And some offer adaptive feedback. And then do things like Carnegie Mellon's Open Learning Initiative, which provides feedback on performance on individual problems. Okay, finally, we mentioned the technical challenges before. I'm not going to do this again. Pedagogical implications. We've been talking about these the whole time, but how much teacher agency do you want in offering the course? Faculty and student buy-in, and the cultural resistance to these potentially different and varied modes of learning, departmental institutional buy-in, freedom to experiment, the opportunity for competency-based credit if students demonstrate competency on a smaller than whole course level. And that is potentially at odds with the seat time credit model of many institutions. Mode of instruction, of course, needs to be in consideration. Is it a fully online course? Is it a blended face-to-face course? Meaning, do the students have laptops in a face-to-face class? What are the teacher goals? Do they want to address differences in background knowledge? Or are they looking to appeal more to the different learning styles, preferences, or goals? As I mentioned, this question and challenge of how does whole class instruction, cohort-based instruction happen if students are not working on or not learning the same content elements? Challenges for peer learning, mentoring, collaborative groups, project-based learning. But at the same time, I could present, this is where a clear gap in the research and adaptive learning systems is, on how they could be an opportunity to support better peer learning or peer mentoring collaborative groups. If the system has a representation for one student knowing a particular content, another student not, they could partner, compare those students in a heterogeneous grouping model. Implications for research, as I mentioned, potential to improve student learning outcomes, retention, engagement in the course, to better inform curricular development, to better see the connection between the cognitive factors, if it is tracking or if it is assessing or surveying, creating a model of student cognitive characteristics, and the connection between that and performance analysis. And finally, challenges to data acquisitions. Mentioned the big data challenges. I know this is something that we're running into C21U with Coursera courses, that we have access to large numbers of large volumes of data, but we're not able to access that data at a fast enough turnaround time. We're not in real time or not at a small enough turnaround scale for teachers to take action within the time span of a single course. And that may be a technical problem, or it may be a regulatory or institutional problem. The concerns about data privacy, the involvement of a third-party adaptive provider in addition to a learning management system raises questions about the privacy and security of that data. Who's getting access to it? How are they using it? Who are they selling it to provide these recommendations? Okay, thank you. And we have the remaining 15 minutes or so.
So how long will it be until Coursera and Udacity and edX integrate some of these capabilities directly or acquire one of these companies?
It's an interesting question. I'd say that's not something they're talking about publicly, but I think the fact that most of the adaptive providers have a huge market in online courses, and most of the universities using them are primarily online universities. I think that really is a next step, or maybe a low-hanging fruit for Coursera. We know that they've had many challenges with peer learning and peer grouping, and how to do peer feedback with peers that maybe have the different ability or different background knowledge. So something like this can provide more information.
Do you think that broad sweeping initiatives by the government, or even on a statewide level, like the Common Core, is going to have an effect on these particular adaptive things?
So something like Common Core would allow larger scale adoption. That's why a lot of textbook publishing companies have really been in favor of Common Core, because they can have material that is easily generalizable to usable in different states. So I could see that as being a benefit, where say you can tag content elements with Common Core standards, then it seems like that would lead to greater adoption. Other questions, either about some of the components of the.
Yeah, so it's interesting. You started off by talking about personalization, and there's also been a discussion about personalized medicine, and it's very unclear whether or not personalization means personalized to an individual or personalized to an individual as a member of a group.
That's right.
And you came to the same point in your talk when you talked about social dynamics. So at what point does context play a role? I'm asking, can you have too much adaptation? Can you try to narrow in on an individual to the point where you miss the social, cultural, economic, genetic, whatever it is, context that makes that individual part of the group?
Absolutely. And I think that is, for me, one of the risks of this, is that it leads to the vision of learning as 30 students, each on their own laptops, nobody talking, never having any interaction between them. That is completely anathema to my personal educational values and a lot of educational research in sociocultural dynamics and sociocultural learning. But I think, and I do want to push back, and at the same time, there's opportunities for personalization within a group, right? And this goes back to the opportunities for more informed peer grouping, more informed peer mentoring, even project-based learning, where 5 students working on a project might have the same project they're working on, the same ultimate goal, but if the system is able to understand their background knowledge, their prior knowledge, which say, course standards, mentioned Common Core, which Common Core standards Rich has performed worse on in the past, and he needs to focus more on for this particular project versus which ones Kristen may need more focus on for this project. So I think it's both, right? There are risks for it to lead towards that, but potentially opportunities for using it to support personal interactions.
So it's, you know, there's a 100-year history of pushing education towards a factory model. And you know, massification of education in the U.S. has meant dividing people up by age and by subject matter and moving those groups through a process.
That's right.
So what I'm taking away from what you said is that there's a different cut at that, where it's not by age, it's not by subject matter, it's maybe by other groups to which a student may be member.
Right, and it seems like the primary one is mastery of content on a granular level. Not did you master Algebra 1, but which course elements within Algebra 1 did you master? Because you may have failed the single unit that was most critical for the next course you go into. But that does require rethinking of seat time, credit hours versus competencies on a smaller level of granularity. But I don't want to necessarily oversell and make snake oil promises for the. Of course, this is going to revolutionize everything and make everybody learn all about it efficiently. But I think it's currently at an inflection point where it could tend towards more individual student freedom and agency and personalization beyond the usual teacher differentiation leads into remedial, on level, or gifted, right? And there, there's a huge range within the mean within those two standard deviations of granularity that does not get addressed.
Rich, in medicine, the term personalized medicine is being replaced by precise medicine, just for the reason that you mentioned. It's not really personalized, right?
So, but the problem in precision medicine is that you can be too precise. So you've got a disease like cancer, and you may narrow in on a specific mutation, but there's a whole family of mutations that make up the same disease. So you learn a lot by membership in the group, and if you zero in on the wrong causal factor.
There's the statistical problem of overfitting the model.
Yeah, that's exactly right. Yeah.
Right. So that's certainly a risk for sure. Other questions? Yeah.
I was trying to connect some of the things you were talking about to online homeworks, because I'm in the School of Math and we've had some discussions about different platforms for online homework. And the thing is that a lot of these overarching educational models in practice, I think, get supplanted in conversations by more practical discussions about which platforms students find easiest to use, or how easy it is for the instructors to use them, and how easy it is to recognize the answers, right? Because you might give an answer not in simplified form, and so I'm wondering just how all those considerations fit into the more sort of high-level concepts you've been talking about.
Certainly the training and adoption curve is an issue, and how likely are individual teachers to adopt this, if it's mandated from the administration of the school. Do they adopt willingly, or are they even able to? Like say, author a course, are students, and then there's the question of how much students have to spend time learning how to use the system versus reaping the benefits from actually using it. So that does not really get addressed as much in the literature as much as it should. I included it here as a consideration, as a challenge, but there are very few studies on how those affect the adoption and the efficacy of the platforms, and I think it's a gap in the literature for sure. The other piece you mentioned about the recognition of student answers varies very heavily from provider to provider, whereas some may have very robust or might have a lot of tolerance for variation of format in student responses. Others don't. And that's not always made clear by the product descriptions or even a demo or a walkthrough for subscription. So that's very, very much, I think, an implication.
Yeah, for us at least, that's a really big deal. I don't know, how different it is in chemistry or engineering or something else, but,
Sure, yeah.
but I imagine that that's something, it's, we had a system that was ideally designed in terms of each tag at each node, leading to the ideal next step, but students get frustrated by the fact that their answer is some function that's expressible in a different way, and it tells them they're wrong, and they haven't mastered this yet. It defeats the purpose.
That's an issue for any technological input program, be it browser-based or app-based or online course assessments for Coursera. So I think one of the opportunities in this is that, so I mentioned we at C21U and Paul Baker, the CACP is now, are in talks with LoudCloud, which is one of the providers. They're very much interested in having faculty conduct research with theirs. I've also been speaking with several other these providers who would potentially be interested in research collaborations. So if that's something that you or faculty might be interested in doing on a small single course level, maybe to either complement or supplement the work that we're doing with classes and MOOCs. Other questions?
All right, please let me thank Michael. To let you know about upcoming events at C21U, our next event in this seminar series will be a panel with instructors who have flipped their classes, and that will be on April 23rd at 11 in this room. So if you are at all interested in flipped classes or flipping your class, they can help you learn about that. And we also have an event coming up on the 15th of April that will be screening the documentary Ivory Tower, which is about the cost of college. And before that event, we'll have a panel of experts to discuss that topic. And so that'll be April 15th, starting at 4 is the panel, and then starting at 5 is the screening, and then Class Auditorium downstairs. So thank you.
The slides from this will be up on the C21U website if you'd like to. So I'm a master's student right now.